notice.
Hello everyone. A very good morning to all of you. Welcome to today's webinar on value of information management in AEC Industry. Thank you all for taking me the time to join us today. I hope all of you can see my screen. To introduce myself, I'm Nagaratna, associated with Desapex as a business analyst, and I'll be responsible for hosting this webinar today. I would also like to introduce today's speaker, Mr. Santosh G, associated with Desapex as a digital design manager. Hi Santosh, welcome to the webinar.
Hello.
Before starting our webinar, I'm going to brief you about today's agenda of today's webinar. I'll be introducing you about Desapex, and Santosh will be briefing you about the key concepts of data, information, knowledge, and you also explaining about metadata and importance of information, and you also stating the key problems in AEC industry, principles of BIM, and defining the information management for AEC industry and its processes, framework, and benefits. Let me introduce you to Desapex. Desapex is a digital engineering organization working towards digital technology integration in the AEC industry to improve the life cycle of built assets. We provide complete digital solutions throughout the life cycle of the building or infrastructure, that is, design, construction, and operation. Desapex aims is to create a sustainable built environment by enabling digital adoption and integration of technologies for target value design. We are at headquartered at Bengaluru, and we're also operating from three major cities in India. Those are Chennai, Hubli, and Hyderabad. And we're also serving our clients across the globe. These are some of the customer segments which we're serving, starting from hotels and restaurants, corporate real estate, residential building, educational institutes, data centers, metro railways, logistics and warehouse, factory building, retail, infrastructure. So wherever there is a capital expenditure and operational expenditure involved, we provide digital solutions over there. Construction industry is facing multiple challenges in this digital transformation era. Majorly, poor coordination between the stakeholders and designers, complications arising midway during construction will cause poor productivity. 2D drawings can cause miscommunication between the stakeholders, and it is very difficult to enrich visualization content such as animation, rendering, etc. Running a project without good project management is a false economy. So it often leads to an unnecessary burden on the budget. If the facility data is not properly transformed to the client at the time of handover, and the data will be lost with the passage of time, these will cause difficulties for retrofitting and renovation in the future. The lack of standards and regulations can result in the tragedy like the structural collapse, fire breakout, and general deterioration, etc. Sustainability and efficiency it can be one of the most challenging aspects of this industry. So it also contributes 11% of the world's greenhouse gas emission. To come across all these problems, we came up with a digital solutions, which are three verticals of Desapex. Starting from digital design management, digital project management, and digital asset management. Under digital design management, we provide the solutions for classification and coordination, including architectural, structural, mechanical, electrical, plumbing, and firefighting modeling, and also BIM-based pre-construction services. At Desapex, We provide our clients to translate the conventional 2D drawings into the 3D BIM models and perform these simulations before even go to the construction site. Under the project management, we are providing to our clients to manage their construction project digitally, where we provide a digital information delivery plan and technical due diligence and setting up a digital lab. Coming to the digital asset management, here we assist our clients to digitize their project document in terms of the latest as well 2D drawings into 3D BIM models. And we also digitize the existing physical building like the building after the handover stage or during the operation stage. Partner with a Finnish company, Granlund. We have an integrated tool called as a Granlund Manager, which is used to provide the solutions like BIM for facility management, in which we provide a maintenance management, energy management, asset management, and also realistic portfolio management services using the BIM models. Regarding digital twins, using reality capture, here we build the models by using the laser scanning technology, and we are going to develop the BIM models using reality capture data, and the model can be further used for as-built, verification and documentation, and also for the construction progress monitoring. We have a developer team capable of integrating design and construction parameters into a digital information model which blends the expertise in domain, process, and tool and provide the owner an unmatched performance. And this is our approach to deliver quality projects on time. This is our young passionate team, and we have civil, mechanical, architectural, and electrical BIM engineers under the leadership of Mr. Srinidhi and Varun Kumar. This part is a USP of the Desapex. I feel very proud to say that we are the first company in the world and only company in the India to have this BSI kite mark from the British Standard Institute, which is a global standard for BIM, and it is ISO 19650 Part 1 and Part 2. This is all about Desapex portfolio. I would like to hand over now to Ms. Santosh for further session. Over to you, Santosh.
Good morning and good evening to the people from the other parts of the globe. I'm Santosheji. I'm associated with Desapex as a digital design manager, and my role is to look after the overall project management and its delivery. As Nagartana previously said, so this is the agenda for today's session. And before we jump into these topics, we request our participants to take the next 10 seconds to let us know their professional background, just to have a feel of the audience. So let's start the poll. So all the participants can just navigate to the left corner of the screen and just answer the poll. These digits look great. Thank you. So let's start with few key concepts like what is data, information, or knowledge. They sound like they mean the same sort of thing, but in computing, they have well-defined meaning. In BIM, we talk a lot about data, information, and the knowledge. In fact, the I in BIM is information, which the industry has tended to forgotten and only concentrated on the M, which is the modeling. So let's have a look at the basic definitions. Data means items that are presented without context. These items can be numbers, texts, images, sounds, or anything that the computer is able to store. At the right, here is an example of data. You can tell that it's a load of numbers, but you don't know what they mean because there's no context. Information is items which are represented in the context. For example, at the right, here is the data from the previous example. These are the same numbers as before, but this time I have put them in a table, and it's what they mean by adding the headings. I have turned the data into information. Knowledge is the ability to take the information and use it in being able to make judgments, form opinions, or create predictions. Here is an example from the one which we took for information. You must have figured out this is an hydrograph, a plot of flow rate of water at a particular location over the time. If you give this information to a hydraulic designer, along with the informations like survey maps and so on, they could use this knowledge to predict where the next floods could happen. Now let's understand what is metadata. The concept of metadata is a simple one and is an important one for BIM and information management. Metadata is the data which describes the other data. What does that mean? Well, think of something like a book. A book contains the data, hopefully quite interesting data. Otherwise, it's not a very good book. Well, there is also a bits of data that describes the books. These are attributes such as the title, author, type of genre, price, publishers. All these describe the book and help us to classify it. Metadata is really helpful for telling us how things are apart from one another, or for finding a particular piece of information in something containing lots of information. We use metadata all the time, but probably without noticing it. BIM enables us to use metadata in the same way to describe our assets. For each of our assets, there's a lot of different types of metadata that we'll be interested in, like the types, coordinates, which type of facility, the contacts, documents, spaces, zones, and so on. By making sure we collect this metadata and doing so in a structured way, we make it easier for ourselves to find things about our assets later on. One of the things metadata allows us to do is to place our data in various classes defined by the needs of the organization. Now moving on to the importance of information. In today's digital world, we are surrounded by data. Some might even say too much information. But it doesn't make any difference until we begin to organize and categorize that data by assigning values of trustworthiness, responsibility, historical background, liability, and so on. As seen in the previous slide, metadata, or the data about the data, is what makes information useful, actionable, or meaningful. For meaningful structured data or information, we can begin to learn, which, when combined with experiences and insights, gives us an understanding and we gain the knowledge. The future will be created through information, which is produced, managed, and coordinated by all the players in the AEC industry, especially the asset owners and the facility managers, or I would say anyone interested in the digital information as it relates to the built environment or the AC sector. In order to realize the importance of information, let's answer a few questions. What's the relationship between the information and the project performance? And the second would be, does quality of information impact on the project performance or the outcomes? There is very little we can do without information. We can't communicate design intent, or might be any compliance or instructions for the safe fabrications, assembly, and construction without the information. And it will be very difficult to safely maintain and operate a building or a piece of infrastructure without any information. To carry out any task successfully, we will need the right information available at the right time to instruct and communicate to the people carrying out the task what is required. And of course, you need the people to understand the information and execute the task in accordance with the instructions. Next, what if the information is wrong or late or missing or difficult to understand? Well, the task will either be delayed or executed incorrectly, or the people executing the task may make some adjustments based on their own experience to try to get the task complete anyway. But the work may still be done incorrectly, and there is a potential risk that it may have to be corrected again later. It may eventually get completed correctly, but there will be a cost and time impact, or you have to accept the incorrect work. So clearly, there is some relationship between the information and the project outcomes, or we could say the performance. And there is obviously a measure of quality of information that impacts the project outcomes or performance in either a positive or a negative way. So good quality information is that one which supports the outcomes and performances, and poor quality information is the one that detracts or hinders the outcomes and performances. I would say good quality information could be categorized as being accurate, on time, available, and clear for the people who are executing the task. And poor quality information could be categorized as being incorrect, unresolved, or late, unavailable, or finally like unclear for the people executing the task. Moving on to next, the key problems in the AEC industry with respect to information management. The first one being the use of data and information throughout the asset life cycle. In the AEC industry, the team works in silos to plan, build, operate the assets. They produce, collect data in different ways with no common rules how it should be all managed. This means the transfer of data and information was disjointed and often incomplete. As a result, at each handover stage, some of the knowledge gained about the asset would be either lost, and the incoming team would have to spend time and money to rediscover it. The second key problem was that teams were not making the best use of the digital tools to deliver their work as efficiently as possible. The industry had largely moved from the paper-based drawing to the computer-aided design, which is CAD. But in doing so, they simply replicated their paper drawings in digital formats. To solve these problems, the industry had to adopt BIM. The purpose of implementing BIM was twofold. It puts an universal structure and standard processes for managing data and information. This means the data and information is collected in the same way throughout the asset lifecycle. This facilitates collaboration by making everyone use the same data in a consistent way. It also improves the handover from the project phase to handover phase through to the operation phase. In this way, the team working on each stage can easily pick up the work done by the previous one. So they can immediately start building on what was done before. It also pushes the industry to adopt new technology to deliver more work efficiently, which includes things like 3D modeling throughout the asset life cycle. So an asset can be virtually built and operated, and potential problems discovered and solved before a spade gets into the ground. Now, as we know the fundamentals of data, information, and knowledge, let's talk about the principles of BIM. The principles of BIM are that we need a digital representation of the assets that we build, as well as by creating the physical assets in the ground, we build some sort of digital model of it, which contains all the data we need to operate and maintain the assets that we receive, and store the asset data in a structured way that relates somehow to the assets we have built. In other words, we make sure that information is received in a consistent way in all our projects, which enables us to find it easy at the later stages. and also create a single version of truth that everyone works on the same data in the common data environment, as this stops the silo working and helps collaboration. This also builds trust in a system and confidence in our data, which strengthens our knowledge. Considering the whole life approach of the assets we build, BIM is about changing the way we deal with data and information, and which is better information management. We can call BIM as better information management, and calling it information management is our only opportunity to get BIM right. BIM was never meant to be just about geometry, but the reality is that's what it has mostly become at the expense of the other equally important forms of information. We need to allow each project participant to capture information that's most suitable to their needs. And we need to start thinking about how to manage and connect all types of information in a project. Dropping the modeling from BIM and simply calling it management allows us to achieve the vision that the fathers of the BIM intended without being limited to any approach. Information management is the industry's opportunity to get it right and to truly digitize and automate the processes across all functions with or without 3D models. Think of it in this way. At the moment, we receive files which have information and data buried in them somewhere. The asset management team should use a data store which contains all the data and information about all the assets they operate. So when a new asset gets handed over, they need to make sure they collect the data and information for the new asset. In this scenario, someone needs to manually extract the data from the assets and add it to the data store. And this obviously takes a lot of time. The end goal of the BIM is to construct a model of the assets we build, which contains the asset data. Then we use this model and the data built into it to extract the reports, drawings, schedules, and so on. In this situation, we can generate documents from the model, which means they get updated as the model gets changed. And more importantly for us, since the model contains the asset data, when we want to hand over the final assets, we can simply export the data from the model and automatically transfer it to the asset data store. This, I would say, improves the collaboration in the project team and makes it easier to hand over the asset data to the operator when the project is complete. The definition of information management in the AEC industry is been referenced from the KPMG UK report on the value of information management in the construction and infrastructure sector, which was published in June 2021. As you can see from this image, this clearly articulates the information management as something that supports the digital transformation and supports a lot of other ongoing transformation initiatives in the sector. So the definition is information management is the process by which an organization creates, manages, stores, uses, and shares its data to perform its core business across the asset lifecycle activities. In the instruction sector, information management is enabled by the application of the national BIM standards or the international BIM standards for BIM, which are ISO 19650. And it also supports the wider digital transformation approaches, which are the data analytics, data science, IoT, artificial intelligence, and also the machine learning applications. Together, these approaches improve the quality, availability, and timeliness of the information available to the organizations, also facilitating more efficient and effective decisions and investments across the asset life cycle, and also being a key enabler of digital transformation. The chart also focuses on the processes, or what you call it as the activities of information management, which are the data specifications, data distribution, production, maintenance, storage, archiving, assurance, and security. Now let's get into these definitions of all these activities. Specification of the data. It is the act of defining an organization's data requirement and the allied processes to fulfill different organizational purposes during the respective stage of the asset. Data distribution is the act of enabling appropriate access to relevant data for the users. It might be both internal and the external to the organization. Data production or acquisition is the act of data creation, which is an output from any of the processes involved in designing, building, operating, maintaining, and disposing of a built asset. Data storage and curation is the act of collecting the data, associating it with the existing data, and storing it to enable the access. Data maintenance is the act of ensuring the data is maintained to specified standards while in use and continues to satisfy the organizational purposes. Data archiving, or what you call it, disposal, is the act of managing the data that is not in active use or deemed no longer required by archiving it or disposing of it, respectively, as per the business policies. Managing data security is the act of securing data at all the steps of the above processes in compliance with your organizational information security policies and other standards to restrict access to authorized users and purposes only. Data assurance is the act of quality assuring the data against specified requirements. And all these processes are meant to be complementary, and it should be built either on the national standards of BIM or the international standards for BIM, which is the ISO 19650. When it comes to the frameworks or the benefits, the important thing to focus here is to get away from the projects or assets or very specific level definitions of IM or the information management and move towards the summary categories to capture the benefits that spoke to things that whatever, like a business leader or somebody holding a financial agenda might speak to more specifically. Now we'll take a look at the top left use cases of the IM. First, we have the asset project and the program management. This covers the more classical examples of BIM implementation in the CapEx, OpEx, and in the estimation and the planning phase. In the CapEx stage, the project and the program level information management is used for all aspects of delivering capital projects, both in greenfield and the brownfield, including the design, construction, asset acquisition, end of life, and its associated activities. It excludes the activities that are explicitly identified under other categories, like example, the commercial management. In the OpEx stage, the information management is used during the operation, maintenance, and the renewal of the assets, primarily focusing on the ongoing and the repeated activities. During the estimating, IM is used for estimating, planning, and whole life cost savings relating to both the financial and the carbon cost of the projects or the programs. The second big area to see IM deliver the benefit is the financial commercial functions within the businesses. And everything from sort of timesheets and financial reporting through to better cash flow analysis on the project is captured in this. In this, we got the two sections. The first one being the capital and the financial management. In this, information management is used for the capital management, working capital, cost control, financial management, payments, and other commercial activities. In commercial management, IM is used for contracts, claims, and dispute management, change control, and other overarching commercial functions. The third lens is often spoken in the digital twin space, sort of looking at the organization's planning and response. And there are two main parts for this. One being the long-term strategic and the portfolio planning, and the second being the short-term, the incident management. In portfolio planning and resilience, the IM is used at organization level to aid the longer-term portfolio planning and the resilience strategies. In incident management and business continuity, the IM is used for short-term incident management and response activities. And finally, at the last, there is risk audit and compliance at the key business level for driving the change. Even this has the two main parts. In regularity and compliance management, IM is used for health and safety, regularity, and environmental compliance, including related security and standard requirements. In assurance audit and reporting, the IM is used for assurance and audit activities, including the technical regularities, data integrity and quality, taking into considerations the internal, external, and the regularity tasks. I just conveyed the front end of the framework in the information management use cases within our sector at an organization level as well as the project level. Now let's map these benefits or the impacts of these use cases can have. So what the value that drives directly for an organization, which is the second block in the framework, and looking beyond the organization to the wider stakeholder or the beneficiaries from that organizations which use the information management. This framework is not intended to be a perspective methodology for measuring and quantifying the value of IM. The individual pathways which get you from the left to the right are highly context specific. There are such a broad range of information management use cases and so many range of outcomes these use cases can have. This framework will serve as an overview to the key decision makers or the C-suites to provide that kind of integrated and the consistent basis for thinking through what are the different building blocks of value. In short, I would say there are three key elements. The first is the productivity gains it unlocks for those organizations which use the information management. The second is the growth it can derive for the wider economy. And the third is the social value it can deliver more broadly for the customer, society, and the environment. So let's just jump on into these three categories in depth. The direct value for an organization which use the information management throughout the enhance or increase productivity gains. There are three key drivers in which these productivities can come about. The first is the cost saved or avoided from the use of IM. Through things like increased efficiency, reduced risk, improved compliance, and enhanced resilience, that enables the organizations to deliver better output for less cost, and that itself is a productivity gain. Secondly, an alternative form of gain is the ability to increase the output or the revenue for the same amount of input or the effort. So getting more from our assets and use of IM to spur the innovation and development of new services and driving growth of organizations. Thirdly, it's a sort of capsule of intangible benefits. So things like reputation and culture, the kind of collaboration and the ethos that is created by the use of information management, as well as factors like health and safety of the workforce that are improved through the use of IM. All of these factors are really difficult to measure. But actually, once you think of them through, they do link to the increased productivity in the long run. If you think about reducing the cost of customer complaints, from that improved reputation, or I would say leading to increase the demand for an organization services, or it might be even attracting a highly skilled or retaining your highly skilled workforces. All of these things ultimately contribute to productivity. The use of IM alone is not sufficient to secure these productivity gains. There are other more important factors that go alongside the use of information management, and a lot of them come down to the people and the leadership. And ultimately, as I've already raised, that the point of data collection, they are a kind of continuous improvement approach. We can only value what we can measure. So the more we get better at doing that, we know we will have the stronger evidence. The KPMG report on the value of information management in construction and infrastructure sector provides the quantified evidence from their bottom-up case study analysis. They found that for every £1 of investment in IM could potentially generate over time between 6.90 and 7.40 pounds in total cost savings, and between 5.10 and 6.0 pounds in labor time savings. They also find evidence of information management enabled cost savings ranging between 1.6% to the 18% in the design and construction stages. Secondly, moving on to the area of value in terms of the wider economy. So it's more important, as we know, the value of information management is not limited to organizations that use it, nor the industry alone. The information management itself is a very important sector within the wider economy and has a very strong, what we kind of refer to as the upstream and the downstream economic linkages with other sectors. So the construction sector buys inputs to produce its outputs in terms of raw materials, professional services, and so on. So if you get to have a more productive construction sector and the output of the sector increases, it will pull on the inputs and demand more inputs from those other sectors. So there are gains upstream. And secondly, downstream, the construction sector is pretty unique, is that it creates the capital that is used by all the other parts of the economy. So we have other firms and households across all other sectors that rely on the construction sector to produce and consume their own goods and services. So if we make construction more productive, and that then increases the outputs or brings down the prices for those other sector downstreams, that too has a ripple effect through the wider economy. So those two effects together are captured in the top-down economic modeling. And most of these gains are outside of the construction sector itself, as highlighted here, that leads to the increased household consumption, increased investments, net exports, and ultimately what this means is the people are paid better wages. The two implications that are also important are, what if we were to improve productivity at the different stages of the asset life cycle? It is found that the whole economic gains were greater when we included the maintenance of the built assets alongside of the design and construction. So really, that just underlines those emerging use cases in operation mentioned earlier, and taking that whole life cost approach when thinking about the IM can drive. Through analysis and study, it is assumed that there is a widespread uptake of information management, and as a result, widespread productivity gains across the sector, including the long tails of the SMEs, which we know in the literature, and I'm sure everyone's aware here in practice. There are barriers to the adoption of information management for these smaller firms, which needs to be overcome if we are to realize the full extent of these wider economic returns. KPMG report says they have estimated that every £1 of productivity gains in the design, construction, and maintenance of the built assets could potentially generate around 3.70 pound of additional annual GDP in the year 2051, with most of these GDP gains occurring outside the construction sector, leading to an increase in wages across the economy. Finally, the third area of value is the wider social value for the customer, society, and the environment. And that wider value comes about by the role of information management plays in enabling the higher quality and more sustainable built assets. And this is the value which is typically difficult to quantify or measure. And in many cases, as it doesn't have a maker price that is traded in the economy. I would say, like the GDP, we can put a dollar figure traded, but this still has an important public value. There are approaches indeed by the government, the way it appraises infrastructure investments, looks very comprehensively at this social value and puts the dollar values on such impacts. The challenge is that within the information management space, this is perhaps not so well established or understood in terms of firstly understanding the line between how information management derives social value, and secondly, how do we go about quantifying and putting a dollar value on that public or social value that is created. The two different categories, the social value impacts, when thinking about this in terms of IM. Firstly, the role of IM can lead to better quality, or I would say more reliable services, as you said, higher quality and more sustainable assets that provide a benefit to the end users of those assets. So less disruption or the less downtime of an asset or the more reliable asset to the customer ultimately provides them with a benefit. Similarly, if you are able to bring down the cost of services they receive, that too provides a benefit to them. But beyond the direct end users of the infrastructure, there are what we refer to as the externalities in the construction and the operation built assets. So when you start to think the role of IM can play in improving sustainability, for example, bringing down the carbon footprint of a built assets, we know that clears the carbon impacts and has a wider cost to society, and it's possible to put a value on that. This is an area which is not so well understood currently by maximum of the organizations, and they never think from this outset about their social value and building that into a kind of investment case for IM. And even if it was done, it was more focused on the metrics that had more financial implications of the organization rather than thinking about the social value in its broader sense, even if ultimately had no direct bearing on the organization operations. The KPMG report gives a quantified evidence from their bottom-up case study analysis through the first organization CPS, which estimated the benefits to the road users and the environmental potentials were worth 11 million. And from an organization named as Edoret, the estimated benefits to tenant society and the environmental potential was worth the 61K per homes. So that's all from this webinar. Thank you. I would say similar to this webinar, Desapex has hosted many other webinars before on various topics and will continue to bring out more according to the needs of the industry. You can reach out to our team, I would say, to get better details of the previous webinars and can even request a personal demo if required. Thank you for joining the session. Over to you, Nagadana.
Thank you, Mr. Santosh, for sharing the valuable insights. I hope all of you have a brief knowledge about value of information management in the AEC industry. If anyone has a questions, can drop the questions in the chat box.
We have one good question dropping in, which says, for gaining all the values, can you explain how we should manage the information? I would say a good one. There is already an instruction manual, I would say, that tells you exactly how to do it, which is the international standard for organizing and digitizing the information about buildings and the civil engineering works, which we refer to as the ISO 19650. It is also the management system that supports a project management system in terms of the international standards, which is ISO 21500. And also it supports the asset management and the overall quality management system from the ISO terms. But what we have learned is it's not that simple with the silos working nature of the AEC industry. Well, the problem is that the construction industry in general does not follow the standards, as I would say, kind of everyone has their own way of doing things. It is all well to have standards, but if nobody follows those standards, or there is no requirement, regulations, or I would say even some government legislations to enforce the standards, then they will have very little effect or no effects. Any other questions?
Thank you so much, Mr. Santosh, for sharing a very informative and valuable session. And I would like to thank each and everyone for joining us, and will connect again soon, and will bring more and more interesting topics in our industry. So stay tuned with the Desapex at LinkedIn and all our social media platforms.